So we're going to determine if this function has an inverse function. Something to remember is that if we have something like this, the inverse is just reflected across the line y equals x, and let's see, that would be reflected there, there, there. So that would be the reflection. Hopefully you saw how I did that. All I'm doing is making this and this the same distance, this and that the same distance. The distance from there to there is the same as there to there. Distance from there to there is the same from there to there. That's how I get a semi-accurate reflection over that line. But if we have a function like this, or sorry, if we're determining if the function has an inverse, the easiest thing to do is just to graph it and then reflect it over this, and then if it passes the vertical line test, then it does have an inverse. If it fails, then this does not have an inverse. Another way you can think about it is with the horizontal line test, which is the same thing as the vertical line test, except for you doing it horizontal on the original function. That was a lot. Maybe you should rewind that. I did that kind of quick. But if I have more, the horizontal line crosses the function more than once, then when I reflect it, it won't pass the vertical line test. That's why the horizontal line test for inverse functions, that's why that's a thing. Because once you reflect it, you can use the vertical line test for functions. So in this case, I already know that this is going to be a parabola and it's going to be opening upwards, and there are no restrictions on the domain. So I'm not even going to graph it accurately. I just know that it's going to be opening upwards. I want to graph it accurately, but it's going to be opening upwards. So if I reflected it, it would be opening sideways. That would get reflected over there, this over there, this over. It would look like something like that, or yeah. Well, this doesn't pass the vertical line test, so this does not have an inverse function. But here's the thing: if we restrict the domain, say if we had y equals x squared, same thing happens there. If we reflected it, we would get the second thing that I drew. However, so this one would not have an inverse function. This does not have an inverse function. However, if you restricted the domain for x greater than or equal to 0 only, then you wouldn't have the two things. It would pass the horizontal line test. So x greater than or equal to 0, that would look like this. Well, if I reflected that, that's bad. If I reflected that across the line y equals x, I would get that. So the second one is definitely a function. So it depends on some kind of restriction. I mean, that helps. If there is no restriction and your function doesn't pass the horizontal line test, it does not have an inverse. If it passes the horizontal line test, it does have an inverse. If you restrict the domain and then it passes the horizontal line test, yes, it has an inverse on that restriction, or based on that restriction. Hopefully that all makes sense. The easiest way to do these things is to graph it and then imagine reflecting it, or just look at the horizontal line test. Hopefully that helps. I think I'm going to be done with that. Use your graphing calculator. It's quick.